All right.
Hello, everyone, and thanks so much for joining us for today's discussion, Dispelling Misperceptions in the World of VR, AR, and XR. We have an amazing lineup of panelists for you today, so please feel free to hit them with your toughest questions. A recording of this discussion will be emailed to you after today's live stream, and it will also be published to O3DE's YouTube channel, so you can find it there as well. And when we wrap up today's discussion, we'll have just a short survey. It's your opportunity to tell us what we did well, how we can do better, and maybe some of the topics that you'd like to hear about in the future. So with that, it is my sincere pleasure to introduce Royal O'Brien, General Manager of Digital Media and Games at the Linux Foundation, who will moderate today's panel. Royal, take it away.
Yeah, Nicole, thank you so much. And thank you for having us today. We're going to have a great conversation. We're going to talk about all kinds of fun things from history to VR, AR, XR. We're going to kind of try and clear the air on a few things and get to reality on, what's mythic and what's real. What is it really that we can do with these kind of things, and what are some of the different perspectives? So before we get started, kind of talk about a little bit of background on everybody. Myself, I come from a development background of about 40 years. I've been in the game industry for over 20 years. I've been involved in different games, middleware, software, kind of an old school C++ developer. It's just the way it is. I have fun these days serving as the executive director of the Open3D Foundation and the Open Metaverse Foundation, and of course, as Nicole said, the Jam at the LF. But I do want to introduce some of the other people here. So we'll start with Ian Williams. Ian, he's the Senior Director of Applied Engineering at NVIDIA, and also chair of the OpenXR group at the Kronos. Ian?
Actually, if I can just, hi, my name's Ian Williams. I'm actually not chair of the OpenXR, but I'll hand that off to, but yeah, I work at NVIDIA. My team gets involved in a lot of XR projects, Omniverse XR, various other XR activities, as well as the crossover between what we think of XR focused and maybe location-based entertainment and professional broadcast instances of XR. So lots of different things.
Awesome. And we also have with us today, Sid Moudgil, Senior Graphics Dev over at AWS. Sid?
Hi, I'm Siddharth Moudgil, and I come from an engineering background, and I've been in the gaming space for a very long time as well, like I think 15 years or so, mostly as a graphics engineer. So I've worked on a lot of rendering engines along the way across many companies. So yeah, so I've worked on I've been part of the Open3D Engine's rendering team and have made contributions towards the render itself.
Excellent. And the next one here that we have is Alfredo Muniz, and this time I'll get it right, who is also the OpenXR chair at the Kronos Group, and also CTO of XEED. Alfredo, my apologies there, but welcome.
Yeah, no problem. Hi, everyone. My name's Alfredo, and I'm a CTO at XEED. We're a small startup that does full body motion tracking. And one of our markets is AR, VR, XR. So that's why we're here. I became the chair of the OpenXR working group because we want to integrate our technology into there, but also I'm just very enthusiastic about the tech and I want to see it grow. And the best way to do that is to do it yourself. So here I am.
Awesome to have you. And of course, last but not least, Bastiaan, Olij, did I get that right?
Olij.
Yeah, I knew I'd massacre it. Lead XR.
Nobody gets it right.
Great to have you. Tell us a little bit about you.
Thank you. Welcome, everybody. My name is Bastiaan Olij. I started my journey in the early 90s in the so-called demo scene, being a part of the open source Godot game engine for the past 6-7 years now, where I took on the fun task to add XR support to the game engine, and has since taken over the role of leading a number of volunteers who are working on all sorts of parts of the XR solution for the game engine. So yeah, that's me today.
Fantastic. Well, so we got a lot of great stuff today. A lot of perspectives to talk about it. Let's go ahead and just jump right on in. you know, it's funny, we look at everybody talking about AR, VR, XR, and you have some people are going, why do I want that? You know, who's going to use that? And if you remember, this question came up, I don't know, what, 25 years ago, like, hey, whoever needs a 3D accelerator, why would I use one of those things? I mean, come on, I've already got the greatest games in 2D now. And all of a sudden it's like, yeah, I play Quake, I'll take one of those Obsidian X24s or 3DFX or Voodoos. Yeah, I'll take one of those any day of the week because I want to beat everybody. And so, you know, we look at it where they think, well, technology, you know, it has a need and a place for it to be. And I guess the first thing that I want to put out, if we look at it from that perspective, and this is open for anybody, you know, what do you think, what are you seeing from some of the key players? You know, are there any like surprises or parallels that you might see? Open to anybody.
I was just going to say that I think in general, the key trends within the XR space have been very encouraging, like with so many new companies joining and developing, like first-party vendors developing new devices that are and subsequent generations that are better, that have better hardware, so like better resolution, better chipset, so like more unified memory. It helps push the envelope of immersiveness. It helps, you know, it helps lower the technical hurdle to build applications that can be used in every imaginable way, like not just gaming, but non-gaming.
Yeah, I think, go ahead.
No, go ahead. Go ahead, tell you.
Yeah, I think a misconception. So, you know, I joined OpenXR working group as chair about a year ago. And one of the misconceptions I had going in was, hey, this space is, you know, put together, there's like a direction, companies are trying to take it somewhere. But, you know, speaking with engineers, that's really not the case. We're still kind of looking for what do people actually want to use this technology for? It's almost like we built the headset because it was cool. And now we're trying to justify, yeah, we spent billions of dollars. How do we, you know, actually get net positive here?
Yeah, I mean, it's a good point. I mean, where do people take it more serious than, say, the Nintendo Power Glove? I mean, you know, there's a point when people are going, yes, this is real. We should be using this, you know, not just for fun. I mean, what do you see some different places that are up and coming with that in the commercial space?
I mean, it's used in a lot of industries now. Like, I think outside of, for us as a graphic engineer, we're so focused on gaming. And I think with gaming, we still haven't hit the mark, the technical mark, to get to a place where gaming can become immersive to a point where you can start enjoying it. But outside of gaming, there are so many industries that are adopting XR and VR devices for their uses. I mean, like, you know, you can pick any space like automotive, medical, retail.
I think that's very true. We see a lot of interest, and you know, it adds real value in a lot of those spaces. When you're looking at something at life scale in 3 dimensions in VR, for example, there's a lot of value. There's a lot more value in that than looking at it on a 2D monitor. And then in other situations, say in the medical world, the ability to look at something that's not lifelike, i.e. if you wanted to study a scan of somebody's heart to plan surgery and things like that, the ability to actually look at that bigger than life and to actually, you know, dissect and sort of look at what it's telling you about that person's condition, and particularly because it's so life critical, that again, there's real value in being able to look at it in VR and XR.
You know, it's funny if you think about that. There's that level of fidelity, right? And I mean, people look at it like VR and AR, like, I don't know if you've ever seen The Good Doctor, where it has one of those episodes and everything goes in 3D and it like swirls it around, and you know, but I think there's a balance between gaming immersion and corporate immersion, because I may not need to create an entire landscape in this lush environment. I just need to be able to see something from any perspective and dissect it. But you know, where is that threshold? Where does it cross over where it's like, that's good enough for the hardware we have right now to be worth buying and using? That's either it's worth someone's time to play a game, or it's worth corporate time versus trying to print it in 3D and try to analyze it that way. I mean, any thoughts on that perspective? Where's that line live?
I think we actually crossed that line already. And I think that's one of the big misconceptions in our industry at this point in time, where a lot of people still have the belief like the technology isn't there yet. And while there is still a lot of progress to be had before we are where we want to be, when we look at the use cases that are out there right now, it is very clear that, yeah, even within the limitations that the technology has right now, we actually are at a point where we can increase productivity in a lot of fields by using these devices. It's just that right now, we're looking at a history of science fiction and writing that sort of predicts the world that we envisioned in this industry. And on one side, finding out that the industry is actually taking a different direction in certain areas of what is enjoyable and what is feasible with the technology today, and sort of not meeting the expectations that were made, but at the same time meeting other expectations that we're in the game industry, that we're actually having a lot of games that we all enjoy and that are actually a lot of fun to play and are starting to sell the medium. And in a commercial sense, where we're starting to see, and that's, I think, a little bit more hidden for the general public, but where we're starting to see indeed medical usage, training usages, simulation usages of the technology, where the industry is saying, yes, this is good enough to enhance our productivity. We're going to jump on board this technology. We're going to do something with it because we believe that we can actually get something out of it.
Yeah, I mean,
yeah,
I
I've
think
seen many companies in the Kernes working group that do just that. You've probably never heard of them, but they're all over medical and industrial applications, and they're part of the working group trying to make this thing work for them. Doing things like virtual training, where, for example, if you take a look at YouTube, you search, how do I do this? You'll probably find a YouTube video on how to do it. Well, in the future, it could be, hey, put on this headset, I'll show you how.
Yeah, and I think there's other things, again, may not be obvious from the outside, but say in media and entertainment, things like virtual production, the ability to actually digitize the real world, bring it into a virtual world, and then go, for example, scout the location to try to act as the backdrop to the next production, whether it's a episodic TV or film or such like, and really VR in those situations, the value of being able to look at that in XR and VR and really the whole virtual production technique itself is a sort of an epitome of XR, being able to capture live people against a virtual background, but in one take and in real time. It looks lifelike and looks like it's actually filmed in a location. That's a tremendous success and a tremendous value.
I also think that the line is dependent on the content that you're generating. So if you're running your application natively on device, your goals are way more aggressive because you're talking about doing stereoscopic rendering using the small SoC chipset on device. So you're going to run into performance problems, thermal problems. Another option is you tether it using cable if it's a non-gaming device. Like in simulation space, you can use that, or even use wireless. So you can do all your stereoscopic rendering on PC and then use wireless to send over your swap chain texture video data onto your device and sort of experience it in VR. So it really, there's no generic. I think that there's no generic. I think it really depends on what's the problem that you're trying to solve and what tools are applicable to you. So if it's a gaming device that needs to run on device, as the app needs to run on device, then you're talking about a completely different set of problems versus, hey, we're trying to build a movie production and we have access to, Steam platforms like PC, Linux, and other GPU nodes. And then your goals are completely separate. And it may mean different things.
I mean, if you think about something here, is that if you're talking about pulling in digital twin, imagine what it was if you had to scout an area, but you want to take a shot from an angle that may not be feasibly possible. Like I want to hang 8.5 feet up in the air and look down diagonally, but I've scanned the area to say, hey, this would be great for a shot if I wanted to do this. And in a virtual environment, you become a part of it. And it does change how that production value is done versus, let's see what that might look like if I put you up on a boom. So it is definitely interesting, some of the ways to do that. But, I want to kind of rewind for a second here, because there has been a perception that it's been a failure, if you think about it. And I'm a little curious about each one of your perspectives, and not just as a whole, because when we talk about this, we keep talking about AR, VR, and XR, and they really are different things. So I wouldn't mind hearing some of your perspectives of what you think, which ones have been a failure or have not been a failure in each area, and where you think it lies. So Ian, let's have you start that off.
Sure. I think I'll pick on, kind of VR and maybe it spawns a bit into XR as well. But I think some of the failures may come from the production necessary to create a VR experience that, or a good quality VR experience. However, I do think that things like sort of real-time ray tracing and some of the work we've sort of done really changes that in some ways, because as opposed to having to take content and then, in order to get the quality, produce it, render it, bake all the lighting and things like that, you can actually, it's now getting to the point where the technology, you can actually render it real time. And to the point that Sid was making about, tethered versus remote and things like that, we're also getting to the point whereby we can actually use centralized resources that have the big GPUs, have the big rendering capability, and stream that to untethered devices and local devices. So the combination of kind of freedom or the quality that you can deliver to a device, as well as overcoming some of the fundamental limitations of having to bake lighting and the environment and the quality, I think is actually sort of at a precipice tipping point to really change the experiences and maybe overcome some of those failures.
Interesting. Bastiaan, what do you think? You've had to dive into this a little bit. You've got your battle scars.
Yeah, the way that I look at it is that, for me, there's two parts of this whole story. One is the success of VR, and sort of going back to what I said just a minute ago about the fact that we are not yet living up to what popular culture, what science fiction has promised VR to be. But if you measure it by that, we're just on that trajectory. And when we look at the successes that we have had in the VR industry, I think that VR is actually very successful. It's just that we aren't yet where some people expect us to be, but we'll get there in a couple of years. And in the meanwhile, there is a lot of things out there that are really good. For me, one of the highlights of the year was playing, the Horizon game on the PlayStation 2, which is absolutely gorgeous and really shows off where we are today with the capabilities. And giving a very enjoyable experience. I think in that also a big problem that we have is obviously when we're looking at games, when we're looking at VR, that's in the public eye. That is what people read about. That's what people see. That's what's in the magazines. That's what's being presented. So any success is highlighted there, and any failure is highlighted there as well. When you then move to AR and you move to more professional applications of the technology, that's kind of more in the background. There are big successes there, but we don't see them, because if you have, say, a big success in the medical industry, there's only a few people who really work with that. It's not going to be in the public eye. The same thing that the suggestion that we just made about VR being used in the movie industry and AR being used in the movie industry. There's tons of examples of that I know about. And only some of those come to light. Obviously for the very big productions, we see them in the behind the scenes documentaries that are often being released for blockbuster movies. And we just only see, Steven Spielberg walking around with an HTC Vive or something like that. And you suddenly see like, hey, these guys have figured out a use case for this. And they're obviously bringing big production value in using the technology, or else an environment like that wouldn't be using it. So right. I think that in that it's a little bit more hidden, but it's definitely there.
So what do you think, Alfredo?
I think the space has been very successful in terms of marketing. So by now everyone's probably heard of, VR, AR, XR, which was not the case like just a few years ago. especially with something like the Vision from Vision OS from Apple.
Mhm.
You know, it was their most watched YouTube video, which is like insane for a brand new device that probably not many of us could afford anyway. So I think the marketing has been on point. People know what this is about. What we're still struggling with, in my opinion, is one is the hardware. I think a lot of people don't realize how difficult it is to go from a 2D flat game to like a 3D stereoscopic VR game. Like, if we're already struggling, you know, a lot of people complain about their FPS on a computer game. Put that in VR and it goes in half. So a lot more optimization needs to happen in terms of hardware, but also the software. Like right now, there isn't a good way to translate games where we're traditionally playing, you know, buttons or controller, and to make that a more interactive experience using your hands and your whole body essentially. That's something that still needs work, and you know that's what we're working towards. I wouldn't call it a failure. I would just call it just needs more time to be mature.
What do
I
you
was
think,
going to
Sid?
say the same. I was going to say the same thing. I think that as far as gaming is concerned, the perception there are these misperceptions because I don't think we've reached there technologically to have a native app, 2D app with some of the most basic rendering features running at the goals that are required. So we're talking about 72 to 90 FPS, which is like 11 milliseconds on the GPU, which is like normally like a console game, which has all the GPU power behind it. You know, even they have a target of 16 milliseconds to run a 60 FPS. So we're talking about basic rendering features like just dynamic shadows or simple punctual dynamic lights. We can't even afford some of these basic rendering features. So what a lot of the VR games do, they sort of do these gimmicky solutions where they'll be like, okay, it's a dark world, so we don't have to do shadows, or, oh, let's forget texture mapping completely because it takes too much, it's too expensive to transfer texture memory from system to the GPU. So let's just forget textures. It's just unheard of in any other platforms, but we have to resort to these solutions because the hardware is just not there yet. And that's why people jump into the space expecting full immersion, looking at movies. But when they actually play the game, they're like, oh, there are no shadows. This is not real. Oh, I can see there are straight up rendering artifacts. The geometry is not tessellated enough, or just multiple of like rendering features that are missing. That is just the core of every game these days on mobile and PC and console. And I think that's why there's that disconnect. But that's the bad side. The good side is I think there are technological advances that are happening. I think that the Apple's new device, Apple Vision Pro, I think that has made enough jumps that it will be able to afford us better performance to let us have these basic rendering features in the gaming space. I can't say much about non-gaming space because I haven't had much experience with it, but I think in those cases you can cheat by using, you know, tethered cables or wireless, or there are other ways to get around it. You don't have to run the application on device.
Yeah, I think the reality comes down to this. You know, from a developer perspective, it's seen more of a success. From a commercial perspective, maybe not as much because it hasn't flooded the market per se. You know, the mass application where I gotta have one perhaps is not there. But then bringing up the points that you're talking about, the hardware, you know, people don't understand in many cases that your console is using about 120 watts when you're playing your game, and your PC is using north of 300 watts, you know, that to drive that game. And you plop on your VR and you're like, oh, this is going to be amazing. Newsflash, that's about 20 watts max, or you want a battery. So until we put a depleted fusion reactor inside of your Walkman size battery pack on the side of your hip, and we find some way to thermally dissipate that without frying your brain or your head, yeah, there is a reality line that even your basic consoles are still 6 times more powerful. And mind you, your console is only displaying one screen at 60 frames a second or higher. VR requires you to draw 2 screens at 2 different camera angles per view. And so get those out of order, and you're going to need a barf bag.
Roy, if I can quickly interject, because I do want to put this in perspective a little bit, because what Sid just mentioned is absolutely true for standalone VR. When you look at PC VR, it's kind of in the middle at this point in time. I think we are having two problems there. One is that there's no guarantee that your users are going to have, you know, the latest hardware that is out there, because on the latest hardware, we have enough processing power to make things look really, really good at those high frame rates. When you look at consoles, and obviously the only example that we currently have is the PlayStation 5. But there, I would say the same thing. If you play any of the AAA games on the PlayStation 5, they actually are at that fidelity level that we're used to on normal games. So I think we're right on that cusp of, hey, the hardware is now available to get the fidelity that, you know, we're after in our space. I think the other problem there, which should not be forgotten, is that it also takes studios with the budget and the ability to create games at that fidelity. We're seeing a lot of smaller companies and smaller game studios in the XR space who simply don't have, you know, 100 artists to call back on to create the content, and therefore they go to a simpler visual standard. Or, you know, they'd simply go there because they want to be able to release their game both on, you know, a console and on a headset, and therefore just choose the lowest denominator that we have right now, where we say, okay, if we want to have success in the space, this is the benchmark that we need to reach. Hey, that's a standalone device. That is a device that indeed has, you know, only a sixth of the power of a modern console. So yeah, we don't have the ability to work at that level yet, even though technically we do have the hardware to do it. It's just not, the market just isn't big enough yet. There isn't certainty enough yet for people to make that commitment to make that level of games yet.
Well, I think also, I do think the kind of streaming part of it is underdeveloped at the moment. I mean, there's particularly say at a home LAN or a Wi-Fi and things like that. And with 5G coming here, there's enough bandwidth to be able to get that, you know, last mile from a reasonably sized PC to an untethered headset as well. But to your point about the kind of content there, Bastiaan, yeah, if you're creating the experience for a 90-degree field of view that's on a monitor, all of that content that would normally be cut out of the field of view exists in VR, and it's all going to look the same as that 90 degrees out of 360-degree view. So there's a big kind of content development and quality in that the sort of scenes and environments that does take a lot of time and effort.
Yeah, I mean, the reality is that streaming is definitely one of the ways that we can get there. I mean, I can remember playing Alex casting from my PC to a VR headset, and I was like, all right, this is cool. And it was using Wi-Fi to fire it over. We can do that. We know that as a fact. I mean, there's no question. But, you know, here's the thing. So we have a lot of knowledge in, you know, technical expertise. So here's a question I'll pose to you. Where do you think the biggest problem is? Hardware, software, assets, or just expertise of the development teams?
If I take a stab at the first one, I think it's actually putting all of those things together, probably.
Come on,
it's
cheating.
kind of like it's between them that, you know, that in the sense that sort of is a game going to be interested to also create a client that assumes certain type of platforms, client platforms, as well as a PC that's, you know, there's bridging kind of software and technology that.
But which one's going to cost the most? Which one's the biggest headache though? Because you can choose hardware.
Depends on where you're running your app. Like if it's a standalone application, it will be the hardware. If it's a console paired, just like how Bastiaan mentioned, like if you have a PS5 VR where the rendering is done on a you know, forward GPU, then it actually becomes a software versus content issue. So now you can optimize like a console game where you have a really good hardware. You just need to make sure that your data is compressed enough and your render pipeline is concise enough to meet your performance goals. Then it's a software problem. And then it becomes depends on the type of content. Is it a texture problem or is it a geometry problem? That it really depends on the texture. So it's like I would just stay between hardware and software at this point, and then depending on the content, you can diversify further.
Yeah, and back to Bastiaan's point, you know, companies also have to be willing to do this. So I really appreciate, for example, Capcom and the Resident Evil series, where they're like, hey, let's make these scary games, you know, in VR. And that's been massively successful. Like, those games are out of this world. I'm gonna pee my pants.
I think one thing that's also very interesting in this respect, coming back to the technological part of it, the whether the expertise is there. I think one of the most difficult things in the XR space for developers is, especially experienced developers in you know, the game industry, is to actually unlearn a lot of things. There are critical differences. One of the things that I find very funny in you know, my experience is talking to other developers who are trying to make something in Godot is they're going like, hey, I'm using these effects that I'm used to using in on, you know, on a game to make things faster. And they don't work in VR. And it turns out that, yeah, you know, when you see something in stereo and your brain is able to process depth, a lot of the tricks of the book that people have learned over years don't apply anymore. They don't work. That suddenly the magic falters, and you need to find different ways to approach the same problem. So there is a certain level of unlearning and relearning skills before you can even build something in XR. And you really have to believe in the technology, and you really have to believe that you're making something that people are going to love playing or love using, in order to make that investment of time to upskill yourself to knowing this. I do think that is a problem that is slowly becoming a problem of the past, as more and more studios jump on board, and there's more and more experienced XR developers who hold their hand up and say, yeah, we'll train your people, we'll get them up to speed, we'll teach them what they need to know in order to make a successful game or applications in this space.
Yeah, my personal opinion is that it is most software problem. Like, you know, we have game consoles like the Switch, Nintendo. They're not running the most powerful, you know, console out there, but they're selling a lot, and that's because they make great content. And I think that's what VR is missing the most. Just like, make some good content that people actually want, and then people will use the thing.
Yeah, that was the example I opened up with. Quake, right? I mean, you would play in 2D, but when you could put that 3D accelerator and you actually got to see your first lighting and things changed, it was like, oh, this isn't even the same game. I have to get one of these. And you're right. I don't think we've gotten there.
The good content requires, I think, would require really good tools. Like, I think as part of working with Open 3D Engine, the biggest problem, at least in the XR space, was performance and how to tackle that. So you need really good tools from first-party vendors. So if you're looking at Quest 2 from Meta, we need tools that can do GPU captures, that can show me exactly what the GPU did for that frame, what the passes were, what the inputs and output was, how much memory was used, and how much time it took, which is really complex to figure out because it's tiled GPU. So the way GPUs render work, or they do it in tiled way, in a bucket manner. So tracking performance across a whole pass becomes a more complicated thing on mobile hardware. So just good tools will make this a lot easier to build better content. Like, we need tools to track performance. We need tools to, if you have a GPU crash, or if you have rendering artifacts, or just artifacts in general, you need to be able to debug that. And that, I think, was, for me at least, was an eye-opener on how reliant I am, as opposed to PC, because they have good drivers and good support. They always just work. Like, Visual Studio will give you the cost stack. That's not usually the case for other IDEs on the CPU, and the same thing is on the GPU. Render dot captures sometimes don't work. Then what do you do? So yeah,
it's funny because the big thing about the tools, you know, they can make or break you, because there's a lot of cost that comes in. If I've got to spend 10 times the effort to debug something, then I've got a viability problem, because I have X amount of dollars, the Y number of people to ship a title by Z date, and if it's not feasible, it becomes a really, really big problem. But part of that is because, you know, you have to learn all the small idiosyncrasies for all these different platforms, all these different chipsets, all these different hardwares. But the hero of the day being OpenXR, you know, how do some of these open standards help solve that, and how do they help pave the way?
I mean, that's a very good point, actually, because we're doing a lot of work on the client side for our Cloud XR kind of streaming, and certainly OpenXR is great at unifying the client kind of runtimes, and is a great opportunity for the engines to kind of then provide a standard interface to the runtime that then can be assumed across many platforms, and also have all the information that you need between the game application interface and the runtime to be able to have a full-featured VR experience or XR experience.
Yeah, anybody else have any thoughts on just the XR tool, having open source and OpenXR and some of the tool chain? I mean, how far, let's think about it. You're talking about certain specifics for the hardware chipset, but if that were solved to a certain degree behind an abstraction layer, you know, what kind of real time scale are we talking about here that you wind up saving as a result of it? Any thoughts on that?
Yeah, so let me just give a quick overview of what is OpenXR, because I still think a lot of people find it confusing. But so, you know, basically you have all these different headsets, and you have to be able to program them, like whether that's through a game engine or some sort of standalone library. And in the past, manufacturers would release their own SDK for that specific headset. So people would write applications and they'd say, all right, I'm going to write in the Meta SDK, I'm going to make a meta game. But then all of a sudden, when they had to go over to a different one, like a Magic Leap, they would have to rewrite it again in Magic Leap's library. Obviously, that's a lot of time. You need to hire different teams for different things. So OpenXR abstracts away that layer. So now all these manufacturers, they make functions that you can talk to developers with in a common interface. So it's a lot easier. The idea is you only need to write one application and it's going to work on all these different headsets. You know, no problem, right? That's what we're trying to get to. You know, the reality is there's a little bit of quirks, but we're working on it.
I would say that
in terms of speeding up development, it helps a lot. Like we've heard from a lot of developers that just say, this is a godsend, you know, I'm happy that you made this. And yeah, very positive so far.
I think one of the things to keep in mind here as well is, you know, if we want this industry to be successful, people need to be able to make money in this industry. And when you look at where the big money makers are right now, you know, mostly Quest and PlayStation, you have to look at what is the effort involved in writing software for those platforms, and where is the effort of people who are getting started in this. Well, I can't start as a new developer developing for PlayStation. I need to start on a PC. So if I learn to become an XR developer, I'm likely going to do it on that platform. If I then build something that I cannot publish anywhere else because all those other systems use completely different SDKs and different, you know, interfaces, I need to relearn that, and I need to get into that, you know, buy myself into that ecosystem, which, you know, can be a very costly upfront exercise, and that would hold people back. So what we're seeing from going from that scenario where people had to write different software for, you know, the Steam ecosystem, and a different, you know, code to a different API for the Meta ecosystem, and code for a different API for, you know, the PlayStation ecosystem. That is that is a big barrier for someone to get into this industry, where they much want to say, no, I don't want to deal with that. And OpenXR really solves that problem. Now, that does require everybody to jump on board on the standard, and that's something that we're currently seeing not everyone do. We see that, you know, Sony is an exception. Apple is an exception. But there are enough core players right now who have jumped on board OpenXR that I, as a developer, know that if I support that standard, if I make my game or my application or whatever I'm making in the XR space, if I make it using that APK or that SDK, then I can suddenly deploy my application to all these different platforms and access, all these different market segments, which makes it a much easier choice to jump into this technology.
And it's not just, I was just going to say, I was just going to say that this is not just an OpenXR problem. This is actually like a GPU API problem. You have hardwares from different companies that use different GPU API, and it's an age-old story, especially for graphics engineers, where you have to support different backends for different devices. And for the most custom companies that make the custom engines, they just couple their pipeline for that one API, and then they're done with it. It just makes the engine really inflexible. It's not modular. It's really hard to extend. So, which is why pretty much these big engines like Unity, Unreal, Godot, and Open3D Engine have become the place to build content, because they will build their API under the hood such that they can support all the APIs. So Open3D Engine's case, you have an RHI gem, and then you have a DirectX 12 gem, which is like a plugin. So you can extend to different APIs, and then these engines are modular enough. At least Open3D Engine is modular enough that you can extend it. So when we did our XR integration, OpenXR was just like the most obvious answer. You just like Vulkan, which is sort of the same parallel with OpenXR, except with Vulkan, it's for the GPU API. We essentially just said, hey, Vulkan with OpenXR, that is our integration that we will add first. If somebody else wants to add other integrations, they can. You just have to make sure that your code base is modular enough and it allows your abstractions are clean enough. But that should be the case, or that is the case going forward, and it should be easy for other people to extend it. But yeah, same problem with OpenXR, same problem with Vulkan, is just, you need to have one standard, and there will always be exceptions, and you just have to make sure that if there's an exception, let that company then build the backend for it, or anybody interested in that device build
I was going to add, kind of related to that point, but mention that OpenXR is also not the lowest common denominator. It doesn't force the technology to be the lowest common denominator. A good example that we've been putting some work in as well, the Vario headset, which has kind of retinal resolution, but they've got their own unique technology of the kind of 4-view rendering to implement that. And OpenXR is flexible enough to allow that particular technology to take advantage of how they've implemented retinal resolution and allow applications to build and target that without being, it's not the core OpenXR, it's an extension, but it's very close and close enough such that, if you've implemented OpenXR, it's maybe just that extra little step to take full advantage of the higher end of the technology.
Something I was thinking about, a point that was brought up, and I heard from a couple, was about pipelines, because the interesting thing is that when you change hardware or you change environments, you wind up changing pipelines, because not all two things, process or graphics, are done the same way. And going back to what was brought up earlier, that some are eliminating, different texture features or different lighting features and things like that. How important do you see having a flexible pipeline in that engine that you can adapt? I mean, how much of an impact is it really going to have on the artist? Because let's face it, I've got to get fidelity across the board. So any thoughts on that whole pipeline dilemma?
I was going to say that it needs to be as easy and flexible as possible. So at least with the Open3D Engine's case, it's data-driven. It doesn't have to be data-driven. You could make it code. And I think for us, we ended up deciding you can either build your pipeline in JSON or you can build it in C++. The thing is, your pipeline is highly dependent on your content and your final platform that you're trying to target. So it's very different when it comes to mobile, because you have different hardware. It's very different when it comes to console. It's very different when it comes to VR. So it needs to be decoupled, and it needs to be easily extensible or modifiable. And I think that is the paradigm all of the engines are transitioning towards, because everybody has different needs. And if you want to target if you want to build a generic engine, you need to make that scalable.
When you
But I
say
think, I think on that as well, the move to the, I'll call them explicit APIs on the graphics side, like Vulkan and things like that, allows those pipelines to be efficient and still be flexible. So you can, the nature of how the graphics APIs work allows the pipeline to implement many stages, but still be efficient during execution, such that it hasn't got a whole host of CPU overhead and things like this that are, you know, related to the different stages. It can be very efficient and processed very smoothly, and really ultimately gated by the capability of the hardware, which is the important aspect for performance.
I guess when you say build a pipeline, by the way, you're really just saying disabling certain features or changing certain features when you're talking about that, or are you talking about
work done in the GPU in one frame, right? That's how I took it as. Pipeline is all of the work that GPU will need to do in one frame. That is what I would say is a pipeline. So it'd be like your shadow pass, your forward, depending on the pipeline, forward pass or deferred pass or indirect, or then your bloom, blur, and everything. So that one frame's worth of work on GPU is, for me, is what I would think as a render pipeline.
Right. It's important I wanted to make that distinct, because it's the question, I guess, if you're saying data driven, where I just literally have a JSON file and I go off, off, versus code block, which is uncomment this, comment that, uncomment this, comment that.
And I have worked on engines like that, where you have to uncomment, comment, and that's very painful. Experimenting becomes really hard. Yeah.
And we're seeing a move now in the industry to a much more graphical approach to that, where people can basically draw out building blocks and link them up, and that gets translated to the execution of a certain pipeline. Because indeed, you know, the problem that you have is, if you have, you know, if you've got a game or application that you want to publish on a wide variety of hardware, you're going to have to be able to change the steps, you know, the render steps that are executed on limited hardware to a way that it doesn't do all the costly things. And you want to do that in a way that, you know, the artist behind it, the person who's designed, you know, the game, the level, the app, is still going to recognize their work and say, yeah, I'm putting my name behind this. This is good enough. And you know, that's, I think, where still a lot of difficulty lies, but also where we just, you know, very much at the start of this evolution of devices that we have, where, you know, standalone is still right now the lowest denominator, and the processing power on standalone is still accelerating at such a pace that eventually that gap will narrow to a point where you can get away with just disabling some of the more costly features in your rendering pipeline that just make things, you know, look that little bit more realistic, that little bit more, you know, popping. But it's still on the standalone device. It looks, you know, good enough for people to say, yeah, I'm happy with this quality. And if I may make a very quick side, you know, tangent on that. Going right back to the remark that you made, Royal, about the switch, I think one of the other problems that we have there is, even if something looks really, really good inside the headset, because we have this spatial awareness, we have this level of immersion, the moment that you display the same thing on the normal screen, in an ad, in marketing, it doesn't. Right. The whole thing that makes it work, that makes it look good when you're inside the headset, does not translate to screen. And I often compare it to when the first, you know, 4K TVs came out, and, you know, and you saw the ads on your old, you know, SD monitors. Yeah, you're not going to sell that technology you have to walk into a store and see those TVs and see how gorgeous they are for you to get what this leap in technology is. And the same thing goes for XR. You have to put the headset on in order to experience what makes it special.
Yeah, I guess that comes down. I think the idea here is that, you know, people may like playing fishing in games, but they don't want to be catfished with their games. Is what it comes down to. You know, so big thing here is, what do you think? A lot of you play with OpenXR. You're familiar with what it is, but what's that next big step forward? Kind of what's your just brief thought? What's it need? What's the hotness?
I'll throw one out there. I think some of the technologies that are coming around to represent objects and scenes. So we're seeing a lot of interest, maybe more from the commercial side, say than gaming, but neural radiance fields is a way of capturing reality in 3 dimensions and essentially giving you a volumetric representation of the real world. In a way that can be visualized and accessed through computer graphics, and essentially you can even capture the real world just by walking around with a cell phone and capture a movie of certain objects, and then admittedly with a lot of processing, and that you can turn that object into something that can then be viewed literally lifelike in virtual reality and augmented reality. So that bridging of capturing the real world and putting it into the virtual scene is an exciting area.
Some thoughts on it?
Is going to go into a differential equation. I think, like going from 2D inverted rendering to 3D with good lighting. I think machine learning integration into all aspects of XR is going to, the trajectory is upwards. Because if you think about immersiveness, at least for me, I think about tracking your hands, tracking your facial expression, tracking sound. And a lot of that requires neural algorithms to make sure you have better tracking, make sure you have better expression matching to your 3D avatar. So I think a lot of this is going to really help explore the usage and visibility of XR apps for various use cases.
I guess, so, looking forward, right? We talked about, the past, we talked about the Quake, and we talked about all the fun stuff like that. Just use your imagination, 5 years, 10 years, 20 years. What is that killer app that'll really propel? Any thoughts on that? I mean, let's go a little snow crash here, okay? Let's have fun with it.
For me, what I would want out of this technology is just to be able to replace my computers.
Okay.
Like, when I travel, maybe I have to work. I don't want to have to carry around my laptop and then a bunch of screens. If I need another screen, a keyboard, a mouse, it'd be nice to just pop this on. The finger tracking is good, and maybe there's like some haptic gloves or something that are lightweight, and I could just type keyboard. I can do a mouse without there being an actual mouse. And then I can actually read like text on these virtual screens that's actually visible instead of like a blurry mess. Essentially just reproduce an environment accurately, move things around to how I want it, and have a virtual office. To me, that's what I would like. I think a lot of people would like that. Right now, the technology isn't there. Things are not that high fidelity or that seamless in terms of experience and feedback. But in 5 years, I'm very much looking forward to that.
Nice.
I think one of the things that I find very interesting is how the industry right now is trying to lob VR and AR into one solution. And I actually think that that's not the case. I think VR has a very different trajectory than AR has. And when you look at VR, the immersion, the being in a separate world from reality is actually the thing that is key, where the fact that you're wearing a device that is enclosing you and sort of, taking you away from the real world, that is one trajectory that is going to go its own way. And when you look at that technology, what we're really only missing is the ability to do it properly wireless, so that you have that power of GPUs that you might have on a machine sitting somewhere in the corner of your room, and you're using the device in your just in the rest of the room without cables going all over the place. And the other thing which is really missing in that technology right now is the locomotion side of it. The fact that you're confined to a room space, while in a virtual world, you do not want to be confined to your room. And we still don't have that solved. We don't have a really good locomotion solution yet. We've got a couple of things that come close, but not the sort of thing that would make a Ready Player One world possible. And when you look at the other side, when you look at the AR is a very different use case than VR. You're wearing something that's augmenting your environment. It's something that needs to be comfortable enough and easy enough to wear that you're willing to walk out your door and walk into a shopping mall. You're not going to walk into a shopping mall with a Quest on your head. You want something that is much less intrusive, that's much easier to wear, much lighter, but that is able to interact with the real world and add value in that way. And I think that's environment. We have a lot of ideas for use cases, and again, a lot coming from science fiction, a lot coming from what people have so far being experiencing with or experimenting with, but we don't have that killer use where someone goes, okay, I can't live without that, and that's only possible on AR glasses. In that direction, I do fully agree with what Alfredo just said. The fact that right now we're moving more and more to an interaction with actually using your hands instead of controllers, which I think is a must in that space. But hands aren't enough. You have to wear something that gives something more than your natural hands can do. So something that allows you to interact with things more, or that allows you to feel things. Basically, that's really the thing that's missing there. So yeah,
we're running a little short on time. And I want to get something from Sid and Ian what they think the killer app would be.
That's a good one. I agree with what Bastiaan said about perhaps still looking for that killer kind of consumer app in augmented reality, because I think everyone doesn't want it to be ads, right? That the ads should not be that killer app, because no one's going to enjoy that. But so I think I'd say again, maybe on the commercial side, there is killer apps in terms of augmentation for giving information. For the people who have a job to do, and that job would be aided by having information. That information can pop up in front of them relevant to the thing that they're looking at, and that's kind of a killer app, I think.
Okay, awesome. Sid, you got any thoughts on it?
I would just say that I don't think that there's like a Fortnite using that parallel for XR. I think that it will be hardware improvements. Obviously, whatever the vision that Alfredo mentioned is like the ultimate. That'd be awesome if you can get to that and be able to hold the device on your head for that long and be comfortable with it. I just think that for my different take would be to just provide killer tools. So it will all depend on the tools that exist that can allow you to build these apps. I think it'll depend on the existing Open 3D engines or like that are already in the space, and tools that comes from Firstman. I think they will just empower the third party to build those apps. Otherwise, one app is going to eventually die out. You need the ability to build many apps.
Yeah, that's a really good point. I think, from my perspective, we talk about VR, and I think I like the idea of hand motions and hand controlling. My fear is I'm sitting in an airplane, slapping the two people next to me sitting in the adjacent seats. Here, shift left, shift right. Why do I feel somebody's juice on my hands? Why is the person in front of me screaming? But at the same time, here's the funny thing. Like, I use a set of Unreal Airs when I'm doing that. Why? Because I have that where I keep the keyboard, shut the screen off, and I just use that as my headset. I would love the idea of what Alfredo said, where I can use my eyes as my mouse. I can do simple hand gestures to select and choose, and I can do kind of a virtual typing environment that doesn't take me away from an extreme area. And you're right, you could work in that environment, you could enjoy that environment. There's so much that you could do. Like think about like the Minority Report, right? Moving things and shifting things around without going totally crazy. In regards to AR is a very interesting space, because here's the thing, you're trying to create more of a world than the world that we see today. Just like we love our Marvel movies and we love all this cool CGI, well, the reality is it lets us put CGI in our real worlds through our phones and do things that otherwise wouldn't be expected. You know, I mean, you see these things are advertisements, but imagine looking through that AR side of it, you're going, wow, look at this billboard. You know, look at how New York City looks completely different. Turn it into an anime city if you want to, as long as you don't get killed by a car and you're actually paying attention. So there's so many things that you can change the perception. And I think the ultimate killer app would be where you could actually experience it in a form of a lucid state, where you could do something that's really interesting. What do you got, Alfredo? I hit it down.
Yeah, Royal, if I may, and I know we're over time, but so the thing for me with AR, it would be training. Imagine just putting on this headset thing, and it'll show you how to do things. It'll correct as you're doing things. Hey, you know, do it this way, not that way.
Yeah.
So you can bake a cake.
Yeah.
You can be a mechanic. You can be whatever you want to be, and you don't even have to think about it because your glasses will do
like
everything.
IKEA furniture.
Well, imagine if you're being trained by, you know, a classically trained baker who, you know, they can see video of what you're doing and they're saying, hey, grab the knife, it's over there, and they like show you a thing. Now cut it with this angle. They can draw the angle on what you're actually seeing on your cake, or fold it and layer it this way. Imagine that kind of training where somebody can do that to a classroom of 10 or 20 or something like that. You're right. And there are a lot of applications that are out there. A friend of mine, I think, runs a company, Scope AR. They do a lot of that stuff now where they do the training and you're looking at the actual gear in an AR environment. So I think it's there. I think there's a lot more, but you're right. These things that's definitely a great killer app. So with that in mind, we are at time, which I told you we would. So I really want to thank everybody for taking a moment and, you know, kind of expressing your thoughts and ideas behind this. Hopefully it was a little bit of fun. And, you know, as for that, Nicole, I'll hand it back over to you, and thank you so much.
This has been an absolutely amazing discussion. And like you said, Royal, so much fun to just listen to all of your insights. So want to thank all of our panelists for being here today. And for all of the listeners out there, viewers out there. This has truly been amazing. As I mentioned at the beginning, after today's live stream, this discussion will be available on O3DE's YouTube channel. So you can find it there. We will also email it to you. And we would sure love for you to take just a few minutes to answer the survey. It's just a couple of questions to help us, you know, really guide this series. So again, I think this is really only the tip of the iceberg. There will be much more to talk about. But thank you, everybody. I appreciate it.
I really appreciate it. And for those who are wondering what the YouTube is for Open3D, YouTube, it's www.youtube.com/Open3D engine. So you'll be able to find the video posted up there. Leave your comments, give your thoughts, blast away. This is how we grow. Thanks a lot, everybody.
Thanks.
You.
Bye.
Thank
Thank you.